my name is SLC from SingaporeStudent.com. Today is Saturday, the 21st of April 2012. The topic that I would like to cover today is about the trend in atomic radius. A lot of students memorize the trend in atomic radius. There will be a graph of atomic radius against the name of the elements. A lot of students memorize it because the students don't understand. If you plot the graph, it will look like this. By the way, you can download this file from my website, SingaporeStudent.com. You might need to print this later, but what I would like to explain today is how we come up with all this trend. So instead of memorizing, I'm going to explain to you how we come up with this graph. Now, to do that, you need to download this file. I think the name of this file is answer key. If you open my website, you're going to see it beside the link of this video. And another important file for you is this pattern. The pattern for this file. This file is called trend graph. I think is in PDF. Then you need to print a minimum of 4. Then because we are going to draw 4 graphs, the first one is atomic radius, the trend in atomic radius. So you need 4 of this. If you're making mistake, then you need to print more, maybe. After you print this, then you can try to fill it up yourself. If you find difficulties, you can always go back to this video and see how we can draw the atomic radius by filling up this table. The difficulty of understanding the atomic radius is the teacher is usually explained in terms of words. So I come up with the idea that to understand the trend in atomic radius is better if the student have a certain activity, which is filling up this table. Right? By filling up this table, then the student can understand the trend of atomic radius changes. So if you see on the paper, there will be several rows. The first one is the element. Then we have number of proton, inner electron. Z effective. This one stands for effective nuclear charge, which is the number of proton minus the inner electron. The number of shell and electronic configuration. For this graph, for atomic radius, we don't need to fill up this electronic configuration. We need to write down all the way until shell here, right? So we are going to fill this thing up together. You can print this after you're ready, then we fill it up together. Now, the first one is filling up the name of the element. For you, you might need to refer to your periodic table. For me, I think I remember. After lithium is beryllium, boron, carbon, nitrogen, oxygen, fluorine. Neon, sodium. Now from here onwards is period 3. Magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. It's easy to do that. The number of proton, also very simple. is very easy. Is in sequence 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we draw the trend in atomic radius all the way until calcium, proton number 20. The inner electron is the number of electrons that you have besides the valence electron. So hydrogen and helium is on the first shell, so you have only one shell, so there is no inner electron. So I have 0 here. From lithium all the way until neon, all of them are second period, so you have 2 shells. So the inner electron will be the first shell, which is all of them have 2 electrons. Sodium all the way until argon is in the third period. So the inner electron is the electron on the first and second shell. Total there will be 10. Potassium and calcium is on the fourth period. So there will be 18 electrons on the inside. Effective nuclear charge is very easy for us to calculate. We just minus away the number of protons and we minus the inner electron. So it's easy for us to do. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2 again. The number of shells also very simple for us to do. Hydrogen and helium have 1 shell only. Lithium all the way until neon have 2 shells. Sodium all the way until argon have 3 shells. Potassium and calcium have 4 shells. You might wonder why we need to fill up all this table. You're going to find out in a short while. There are 2 main factors. There are 2 main factors affecting the atomic radius. One is the number of shells. So the more shell you have, logically you understand, intuitively you understand that the more shell you have, the bigger the size of the atom. So you're going to see an increase in the size of atom from helium to lithium. And if you add 1 more shell, the effect will be very significant. So that you're going to see a big jump from helium to lithium because you add 1 more shell. The same thing happens to between neon and sodium. You have a big increase, and you're going to see the same thing between argon and potassium. Yes. So the number of shells have a very significant effect on the size of the atomic radius. That's the first one. Another one is the effective nuclear charge. Effective nuclear charge also affect the atomic radius. The higher the effective nuclear charge, the smaller it is. So you see, if you compare hydrogen and helium, helium will be slightly smaller than hydrogen. So this red arrow represents a slight decrease, a gradual decrease of atomic radius. So from lithium to neon also, you're going to see a gradual decrease of atomic radius. And also from sodium to potassium, you're going to see a gradual decrease of, you're going to see a gradual decrease of atomic radius. The same thing happens for potassium and calcium. Calcium will be slightly smaller than potassium. Now, these two factors affect atomic radius the most. How are we going to draw the atomic radius trend? Very simple. First of all, we are going to draw the trend by the increase of the number of shell. So we have a big jump from helium to lithium, and also from neon to sodium, and also between argon and potassium. And also we need to take into account the effect of effective nuclear charge. So it's a gradual decrease from hydrogen to helium. Also gradual decrease from lithium to neon, and also a gradual decrease from sodium to argon, and a slight decrease from potassium to calcium. So we need to write down just a significant, just some key elements here, like hydrogen and helium here, and lithium, neon, sodium, argon, potassium, and calcium. So if you look at the answer key, it looks quite similar, right? It looks quite similar. So in general, it will decrease across a period, then it will have a big increase when you change the period. We can put an extra explanation here. This is from helium to lithium is because you add one more shell. The same thing happens from sodium to from neon to sodium, and from argon to potassium. And the decrease because of effective nuclear charge, I marked with red color. This is because you have increasing effective nuclear charge, which means decreasing the atomic radius. That's the explanation. So that's how you can draw this trend in atomic radius. I think you can easily understand. So if you don't understand, maybe you can do the exercise one more time. But this is quite simple. So you have this activity. So this is the first trend that can be explained using the pattern here. We are going to draw three more graphs. Ionic radius, first ionization energy and second ionization energy. So later we are going to do the same process, then we can always check the answer on the answer key. I hope this is useful for you. Thank you.